All right, hello and welcome to Physics 2211 Lab 5. Let's get right into it. So the experiment that I chose is a pretty simple momentum experiment, conservation of momentum, where two balls are, or one ball is sent towards another, and then they end up colliding, and then their velocities are recorded along with the time periods that they are moving in, just to find the change in momentum and the change in kinetic energy of the collision. So now this illustrates the conservation of momentum and the mechanics of inelastic collisions, um, since there will be some energy lost to heat or sound or some other sources. And there's no simulation model due to GlowScript not being very difficult to do this kind of thing on there. However, there are a lot of equations used to illustrate the point. So the basic results is that the collision is inelastic, so kinetic energy is not conserved. Um, Ideally, there would be conservation of momentum, but since there is outside force acting on the balls, from the table, there's some friction, there's some possibly some air resistance, there's some other forces that may act on it, which does not conserve the momentum. And then the velocity and the position, like as measured by tracker, is used to calculate this momentum and kinetic energy loss. All right. So the calculations here, both balls had a mass of 0.028 kilograms, so they're pretty small. And then for the initial momentum, these are our vectors. However, we can just look at the x component of them, which is why all of these are scalar quantities, just because the balls are only moving in one direction. So taking the mass times the velocity of each of the balls, adding them together, gets you 0.151 kilogram meters per second. Doing the same for the final with the velocities is 0.133. So then we see that the change in momentum is 0.018. And then from this, we can find that since the average force acting on the object is going to be dp dt, or in this case, delta p over delta t for the average, we'll get that there's an average of 0.008 newtons acting on the force, or acting on the ball, rather, or the system. So now we can look at the kinetic energy as well. This is the change in kinetic energy of the first ball. This is the change in kinetic energy of the second ball. Um, and then we get minus zero point 0.2 joules. So it loses zero point 0.2 joules of energy. Now for momentum, again, this is the change in momentum. In an ideal situation where there was no friction, no heat loss, no nothing like that, the ball system would maintain momentum before and after the collision. However, there's some momentum lost within the rolling period, which would cause momentum to not be conserved, even though it is an inelastic collision. So now net force was also calculated to be pretty low. Um, as we saw on the last slide, it was pretty low, under a hundredth of a newton, showing only small forces on the ball. I think it was 0.008. So the surface does not contribute that much. Now for kinetic energy, we saw also that it was 0.2 joules, pretty small, under 5% of the original energy. If you take uh, M1V, oh, these should be squared as well. I missed that in the calculations. Well, the calculations are correct. I just missed it in um, the equations. However, if you look at these calculations, this M1 V1 F squared and M1 or M2 V2 I or M1 V2 F squared are both going to be pretty large compared to this point 0.2. And this kinetic energy is just lost due to sources such as heat, sound, friction, lots of sources that could have occurred during the collision, as well as whatever was lost during the rolling period to the surface. So yeah, that concludes Lab 5, um, Momentum and Kinetic Energy Experiment. Uh, Thank you to the video that I took the information from on YouTube. It was another group of students that were doing a similar experiment. So yeah, thank you for watching.